Alright, systems of equations. Review. Long review. I'm going to go through it quick. Pause it if you need to pause it. Number one, we're going to start out solving this one. Graphing. They're all small numbers. They're already in y equals mx plus b form. So I'm going to skip to the graph and give you the answer there. Alright, when I graph the two equations, they intersect right here at this ordered pair 4, 4. So for number one, your solution is 4, 4. Number two, we have two equations in standard form. That means elimination would be the best. I want to make the 15s match up, so I'm going to multiply the bottom by 3. That gives me, okay, we multiplied by 3. We have matching 15y's now, opposite signs, so I can add to cancel them out. 15y equals 120, so y equals 8. Go back and plug that into either equation. I'm going to choose the bottom equation. Okay, small mess up. 5x equals 120. X equals 8. So I'm going to plug x, or 8 in for x in this bottom equation. Over here, you get 32 minus 5y equals 27, which gives you y equals 1. And x equals 8. Number 3, I see that there's one equation already in y equals form and one equation in standard form. That means substitution will be the easiest. I'm going to substitute that in place of y. So 2x plus y, which is 4x minus 1, equals 17. When you go solve for that, you get 6x minus 1 is 17, so x equals 3. Take this equation, plug in 3 for your x, so y equals 4 times 3 minus 1, which is 11. Alright, number 4, we have two equations in y equals form. Sometimes graphing is easiest, but these numbers are too big to graph, so we're going to use substitution. This 15x minus 4 is going to go in place of y. So 15x minus 4 equals 5x plus 66. Minus 5x to both sides. 10x equals, I'm going to add 4, 70. So x equals 7. Take either equation, doesn't really matter. I'm going to choose the bottom one. 5 times 7 plus 66. I'm plugging in 7 for x. And I'm getting 35 plus 66, which is 101 for my y. There's that answer. Number 5, two equations in standard form. I'm going to go with elimination. We could use substitution here. We could use graphing. This one's kind of equally difficult for all methods, but I'm going to go with elimination. I'm going to make the y's match up. So I'm going to multiply the bottom equation by a negative 2. Now we have a positive 2y up top, negative 2y down bottom. We can add to cancel them out. 1x equals 0. Yes, that's a normal answer. It's not no solution, not infinitely many. 0 is just a normal one. Take either equation. I'm going to take the bottom one and plug it in over here. 0 plus y equals 5, which means y equals 5. Number 6, again, we have two equations in y equals form. That tells us graphing is the easiest, especially when there's small numbers. So I'm going to graph both equations. This right here is what I get when I graph these two equations. And they intersect right there at 2, 1. Kind of, if my line was drawn better. Okay, for 7, 8, and 9, when is each method easiest? While I was working 1 through 6, I kind of explained why I was using each method. I think if you listen to the last 6 problems, you can kind of get your own answers there. So I'm going to save time and not go over 7, 8, and 9. Number 10, 11, and 12, I'm going to show you the equations and show you the answer. I'm not going to go through how to solve. I think we've had enough practice on solving. Number 10, we have $3.79 for a classic chicken sandwich. We'll call that S for sandwich, and $4.09 for a, I did that wrong. Cheeseburger is $3.79, so we'll call that B for burger, S for sandwich. The total that was purchased was $95.76. I bought twice as many chicken sandwiches, so the number of chicken sandwiches is twice as many as the burgers. There's your 2 equations. Solve them however you'd like. I would use substitution if it was me, and you get the number of burgers is 8, the number of chicken sandwiches is 16. Number 11, Bill hates Sonic, but his wife always wants to eat there. They always argue. Bill thinks it's time for a divorce. Poor Bill. He spent $9.48 on a number 15 and a number 18. We're going to call that X and Y there. The total for X plus Y is $9.48. And number 18, which is Y, costs $2.10 less than a number 15. So we're going to say X minus $2.10. Be careful with the order you write this in. It has to be X minus $2.10, not $2.10 minus X. When we do that, solve it however you'd like. Again, I would use substitution here. You end up with X, which is a number 15, cost $5.79. Y, which is a number 18, cost $3.69. There is your answer. Number 12, the State Fair has 2 different types of hot dogs, regular and jumbo. Regular is $5, jumbo is $7. They sold 7,250 hot dogs. So we're going to say the number of regular plus the number of jumbo equals 7,250. Now the money, they made a total of $46,250. That was from selling regular hot dogs for 5, so 5R, and jumbo hot dogs for 7, so 7J. Solve that any way you'd like. I would go with elimination. I'd multiply the top one by 5 to make the R's match up. And when you do that, you get the number of regular hot dogs is 2,250. Jumbo hot dogs, 5,000. A lot of hot dogs. Number 13 and 14, you have 2 tables. Still a system of equations. It's just 2 equations, but they're given in table form. We have not seen a question like this yet, but they're actually pretty easy. Remember, the solution for a system is the one point that they both have in common. So if you look very carefully, you'll see that on number 13, they both have a 12,2. So that's your solution there. Number 14, they both have a 2 and 18. So there's your solution there. All right, 15, we have another system of equations. Solve it any way you want. I'm going to go with elimination. They're both in standard form, so that looks like an easy elimination problem. I'm going to double the top to get 2x minus 4y equals 6. The bottom is 2x minus 4y equals 6. That's the same equation twice, which means I don't need to go any further. I know that that is infinitely many solutions. Number 16, we have one in standard form, one in kind of a weird form, but I see a 2x and a 2x. I'm going to use substitution and put this, which is equal to 2x, in place of the 2x. So I'm going to say 18 plus 2y plus 3y equals 6. That gives me 5y plus 18 equals 6. Minus 18 to both sides. We get negative 12. And we end up with 5y equals, divide by 5, y equals negative 12 fifths, which as a decimal is negative 2.4. Now that we have y, yeah, it's a decimal, I'm sorry. Oh well, get over it. We're going to take either equation. I'm going to take the 2x equals 18 plus 2y and plug in negative 2.4. And for y, when you work that out, you end up getting 2x equals 13.2. Divide by 2, and x equals 6.6. Alright, 16 and 17, not really much I can help you with on this. You just got to read it and figure out which equation makes sense. So I'm just going to give you the answers here. You're on your own figuring out how. Number 16 is D. Number 17 is A. 18 and 19 are the same way. If you read through there, it's somewhat I don't want to say common sense, but it's relatively easy to figure out based on what they're saying. 18 is H, 19 is J. And the challenge problem, number 20, looks to be really, really hard. There's 3 equations with 3 variables. There's actually a really easy trick that gets this answer. It's the easiest problem on the whole worksheet. All you got to do